Okay, now looking at what's called higher order derivatives. Of course, what you're used to doing is just a first derivative. And of course, these are notations that you're used to seeing. Now, you can be asked to do derivatives more than one time. So a second derivative would just simply be the derivative of the first derivative. So like once you find the first derivative, if you do the derivative of it, then you get the second derivative. You do the derivative of it, then you'll get third derivative, and so on. But just looking at the notation that you have here, like for instance, if you look at this notation, like first derivative is 1 tick mark, second derivative would be 2 tick marks, 3 tick marks. But once you get beyond that, you actually just start writing the actual numerical number for that derivative. But it would have to be put in parentheses, because without those parentheses, then it just looks like you're saying y to the fourth power. Now this is going to be your function notation, again, that you're used to seeing. So first derivative, second derivative, third derivative. Again, once you get past that, then you would just have, just start using the actual number, but again, keeping it in parentheses. This is using the dy dx notation. Now look at the where you have like the 2's and the 3's located. Like in your numerator, they always put the number between the d and the y. But then when you're in the denominator, they put it at the end after the x. So this just means that you're doing a second derivative with respect to x twice. So you're doing a third derivative with respect to x 3 times. That's kind of what that's thought of. Now, instead of just saying like, second derivative, third derivative, sometimes it is like double prime, triple prime is another common saying that they have. Alright, so the first example here, you're asked to find the second derivative. Okay, so you're given this function and you're asked for second derivative. So that means you're going to have to find first derivative to begin with. So the derivative of x would just be 1. Now this is going to be using power rule, so you'll do the -2 times the 32, so that's actually going to give you a -64x to 1 less power, so that would drop down to be a third power. Now if all you wanted was first derivative, then you would need to rewrite this with a positive exponent, but since you need to go ahead and do the second derivative, don't bother rewriting it. Because this is going to be the way you want it to be able to take the second derivative. So you can just do the 2 tick marks now. Of course, the derivative of 1 is just going to be 0. So now you need to do the -3 times the -64, so that's going to end up giving us a positive 192, I believe. And then decrease your power by 1, so now it drops down to a fourth power. Now, since we're just looking for second derivative, last step, you would rewrite it now so that your final answer would have the positive exponents. Okay, next. Okay, same instructions. We're going to find the second derivative. If you leave this one written as it is, that means you're going to have to do quotient rule. Of course, then you're going to have a fraction, and then you're going to have to do quotient rule again in order to get second derivative. I would take a step and rewrite this one. Like I would divide each of my terms by x. So x squared divided by x would just be x. 2x divided by x would just be 2. Now, there's not anything that's going to cancel here, but when you do -1 divided by x, you're going to want to take the x to the numerator. So, of course, this is understood to be the first power. You bring it to the top, then your exponent changes to a -1. So I would use this form in order to start my derivatives. So first derivative of x is just 1. Derivative of a constant 0. Using power rule on this one, so you'll have -1 times -1, so that's going to give you a positive 1x to 1 less power, so that'll drop down to -2. And now, again, don't rewrite it, leave it, take your second derivative. So the derivative of 1 would be 0. Using power rule here, I would have negative 2x to the negative 3 because you drop your power by 1. And now last rewriting this, you would have negative 2 divided by x to the third power. So this would be your final result. All right, so on both of those, you started out with the original and had to do the derivative twice. Now here's what else you're going to have to do with some of your homework problems. They're actually not going to start you out every single time with the original function. Like in this case, see, they're actually starting you with the fourth derivative and they're asking you to find the sixth derivative. So it's basically the same thing we've just been doing. You're just going to have to do the derivative twice in order to get from the fourth one to the sixth one. Okay, so we got to go next. Of course, you got to go to the fifth one. All right, so if this is the fourth derivative, you take the derivative of this to get the fifth. So this is going to be 18x squared minus 18x plus 1. Of course, the derivative of the 6 is 0. So now your sixth derivative, so using your power rule here, you would have 36x minus, derivative here would just be 18. Of course, derivative of 1 is 0. All right, last one of these. Now this time they're starting you out with second derivative and you've got to go to the fifth derivative, so actually that's going to require that you do derivative 3 times. But I would rewrite this one. Like I would rewrite this part so I wouldn't have to do quotient rule. So I'm not doing a derivative yet, so I'm just going to say equals because I'm keeping this problem, just rewriting it. So I would change this to be 5x to the negative 3, and that way you can just use power rule as you're doing your derivatives. Alright, so next would be third derivative. Of course, derivative of 7 is 0. So using my power rule here, this is going to give me positive 15x, drop my power by 1. Again, don't rewrite it just yet until you're actually finished doing your derivatives. So fourth derivative. So again, using power rule, so negative 4 times the 15 is going to give me negative 60x. Drop your power by 1. And again, you still got another derivative to go, so don't bother rewriting it yet. So now your fifth derivative. So now you got to do negative 5 times negative 60, so that's going to give you positive 300x to 1 less power. And now, finally rewrite this. Bring this to your denominator, and so you'll have a positive exponent.